Yeah, yeah. Good evening, all. So before I start, so myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 10 plus years of experience in Hadoop and Spark environment, right? Yes. So as part of today's demo, I'll be covering what is big data, why Hadoop and Spark, drawbacks with the current databases, Hadoop and Spark advantages, Hadoop and Spark job market, right? Yes. So as part of this, right, as part of this course, we'll be discussing big data, Hadoop, PySpark, Linux, Python. Python, Core and Advanced, nearly 50 sessions will be discussed. Right. So before I go, just to go through the course content, what I'll be discussing, right? Yes. Big data Hadoop. What is big data? What is Hadoop? Need of Hadoop, sources and types of data, comparisons with other technologies, challenges with big data, storage and processing, RDBMS versus Hadoop, advantage of Hadoop, Hadoop ecosystem components, Hadoop distributed file system, Hadoop distributed file system. So features of HDFS, name node, data node, HDFS architecture, name node, data node, secondary name node, data, metadata management, storage and processing, map reduce. It is an important processing component for parallel processing. Next, scoop. The first two characters of SQL and last three characters of Hadoop forms a scoop. Scoop import, scoop export, importing data from RDBMS to HDFS. From so importing data from databases to Hadoop and exporting data from Hadoop to databases. So while importing, we can perform different transformations, so filterings, mergings, groupings, aggregations, incremental import. Yarn, speculative execution, speculative job, speculative task. Comparison of Hadoop 1.x and Hadoop 2.x. Comparison with the previous versions. Yarn architectural components. Resource manager, application master, node manager, application manager, resource scheduler, job history server, container, right? And NoSQL databases, NoSQL databases, different types of NoSQL databases. And one NoSQL database I'll be discussing like HBase. And one important component of Hadoop, Hive. Hive is a data warehouse kind of environment. Hive is what? Data warehouse kind of environment within the Hadoop framework. Yes. And also like streaming and streaming component like Kafka. PySpark. Next, PySpark is the important component. PySpark introduction. Why PySpark? Need for PySpark. PySpark features, sessions, Spark context, PySpark RDD computation, PySpark persistence, PySpark core compute, groupings and aggregations, and various actions and transformations, right? Different actions and transformations, and PySpark SQL data frame API, PySpark creating data frame to pandas, structure type, select, collect, and with column renamed drop, group by, join, UDF, Map, flat map for each sample, fill, pivot, array type, map type, right? Yes. PySpark SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions, reading and writing to a JSON file. PySpark built-in functions when expr, lit, split, translate to timestamp to date, date format, create list, collect set, create map, map keys, map values, struct. So in this way, different inbuilt functions of PySpark. PySpark external sources working with SQL statements, Spark and Hive integration, and working with CSV, working with JSON, transformations and actions, narrow and wide transformations, deployment modes, local mode, cluster modes, PySpark application, right? Station task, drivers and executor, building Spark applications, deploying Spark applications to cluster and tuning, performance tuning mechanisms, and PySpark streaming components, integration with Kafka and PySpark MLlib, PySpark machine learning library, right? Yes. And Python, and also Python will be discussed. Python basics, why Python, history, applications, features, advantages, versions, flavors, Python operations, Python modes of executions, Python editors, and data types, Python constants, Python variables, comments, input output statements, type conversions, comments in Python, escape sequences, strings in Python, operators in Python, right? Yes. Operators in Python, arithmetic operators, comparison operators, logical operators, assignment, shorthand assignment operators, bitwise membership operators, Python IDs, PyCharm ID, working with PyCharm components installations. What is Conda, Anaconda prompt, Anaconda navigator, Jupyter notebook, Spider IDE, right? Spider features, flow control statements, indentation in Python, conditional statements, looping statements, while loop, while else, for loop, range, nested for loop, break statement, continue statement, pass statement. Yes, 1 second. 1 second. Okay. Looping statements, while loop, for loop, nested for loop, break statement, continue statement, pass statement, strings in Python, creating strings, string indexing, string slicing, string concatenation, string comparison, right? Yes, collections in Python, lists, collections in Python, list, tuples, sets, dictionaries, functions in Python, different types of arguments, default, non-default, keyword, non-keyword arguments, right? Yes. Modules in Python, what is a module? Different ways of importing, renaming, reloading packages, right? Errors and exceptions, types of errors. What is exception, need of exception handling, and the file handling, right? File handling in Python, right? Object-oriented programming concepts in brief. Class object inheritance, polymorphism, right? Regular expressions in Python, database connectivity, Python data and time module, operating system module, Advanced concepts like iterators, generators, closers, decorators, web scraping. Working with CSV files, working with XML files, working with JSON files. GUI programming components, right? And Excel workbook, working with Excel workbook, data analytics, NumPy, Matplotlib, Pandas model, and introduction to this data science, Python Pandas model in brief, NumPy model in brief, and Matplotlib model in brief, right? This is what the course content will be discussed. Big data Hadoop, PySpark, Python, and also Linux will be discussed. Coming to this demo, right? Yes. What is big data? Why Hadoop and Spark? Drawbacks with the current databases, Hadoop and Spark advantages, Hadoop and Spark job market. Big data, right? Huge volumes of data like KBs, MBs, or you should have seen KBs, MBs, GBs, TBs of data. But today data is getting generated in petabytes, right? Petabytes of data generation, right? Examples of petabytes of data generation, right? Today, like applications like Facebook, which has got millions and trillions of users. In a minute, how many posts and videos are getting circulated? Each and every post has to be saved, right? So what is the data generated in a minute, in a hour, in a day? Huge data, right? In petabytes. Not only Facebook, today, like different applications like Twitter, Google, YouTube videos upload, Gmail messages, bank transactions, telecom transactions, e-commerce transactions, right? E-commerce transactions like Flipkart or Amazon transactions, right? Everywhere, huge data is getting generated. Okay, we have got some databases currently. Databases like Oracle, MySQL, DB2, SQL Server. They are used for OLTP, online transactional processing, day-to-day operations. We have got some specialized databases like Teradata, Netezza, Vertica, used for data warehouse, for OLAP operations. But these databases and specialized databases can handle data up to some extent. Can handle data up to some extent. But for unlimited data storage, we have got a framework like Hadoop. Hadoop is for storage. Hadoop is for processing, for storing the data and for processing data. Any technology either stores or process, but Hadoop performs both storing and processing. So for storage, Hadoop is using a file system called Hadoop distributed file system. It is not using any database, right? For storing its data. Rather, as databases has got some drawbacks. Despite of this databases, is going with a file system called Hadoop distributed file system. And for processing, it's going with MapReduce. Currently, it is going with Spark. Hadoop is not for online applications. Hadoop is meant for batch applications. So there are two types of applications: online applications, secondly, batch applications, user interactive applications. Here user gives the input. Here user gives the input. Here user gives the input. User interactive applications means user gives the input. Booking a movie ticket, making a online making a online payment. Example of this online applications, right? But batch applications, user non-interactive applications. Here user is nowhere required. User is no way required. Railway ticketing, PNR status. Railway ticketing, PNR status, right? Yes. And the credit card statements for millions of customers. Credit card statements for millions of customers. Okay. So, yes, Hadoop is meant for batch applications, user non-interactive applications. Right. User is nowhere required for this batch application. And why databases can't be used for storing Hadoop's data? Drawbacks with the current databases. Very less storage in most of the databases. No parallel processing. As volume increasing, speed decreases. Select total amount from sales 1, total amount from sales 2, total amount from sales 3. So from record to record, observe here, yes. So here if you take total amount from sales 1 has got 10 records, total amount from sales 2 has got 10 lakh records, total amount from sales 3 has got 10 crore records. So record to record as the volume increasing, right? Speed decreasing. Which query executes faster means the first query, right? Total amount of 10 records as compared with 10 lakh or 10 crore records. The first query executes faster. Yeah, even if complexity increases, speed decreases. Even if complexity increases, speed decreases, right? Yes. Um, Select total amount from sales 1, which has got 10 lakh. Average amount. Select average amount from sales 1 and select standard deviation of amount from sales 1. So here, which query executes faster? Again, the first query, right? Because average amount is a two-step process. First sum to be calculated, next average to be calculated, which takes more time than the first one, right? Standard deviation of amount, lot of internal processing required. Standard deviation of amount from sales one, right? Yes. So as complexity increases, speed decreasing. Databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. So this is the major drawback with the databases. So yes, Hadoop doesn't follow client-server architecture. Hadoop follows master-slave architecture. So here Hadoop cluster, group of nodes systems connected in a network. There are two types of nodes, master node, slave node, right? Master node and slave node. Master node response. See here, Hadoop, if you see this Hadoop architecture, single master and multiple slaves. Single master and multiple slaves, right? Yes. S1, S2, so on, S10. This master node, these are slave nodes. Okay, single master, multiple slaves. F1.txt. Hadoop data is stored in the form of files, subdivided into, yes, into smaller part. Each part stored across multiple systems. So the advantage, distributed storage and also like parallel processing, distributed storage and parallel processing. Two advantages, distributed storage and parallel processing. So here, master node responsibilities. As I see here, if you observe this, yes, here master node assigns a T1 task to slave 1, T2 task to slave 2, T3 task to slave 3, assigning three tasks to the three slaves. Who is assigning? Master nodes. To whom? To the slaves. Master node responsibilities: assigning tasks to the slaves, task assignment, balancing the load equally to all the slaves. Fault tolerance. Fault tolerance means here multiple tasks. Observe here, yes. Fault tolerance means here if you observe, multiple tasks are assigned to multiple slaves. So these multiple tasks are executed by multiple slaves parallelly. Suddenly, if any one slave goes down, then the task of it will be assigned to any of the available slave. This process is called fault tolerance mechanism. Who takes care? Master node. Yes. Health monitoring of each and every slave. Slave node responsibilities only to storing the data and processing the data. Yes. Hadoop advantages, right? Unlimited data storage is possible because of horizontally unlimited scalability. Means if you talk about Hadoop, unlimited data storage, because here S1, S2, S3 up to S10. Tomorrow, if data is increased, if data is increased, right, you can keep on increasing the slaves horizontally. Unlimited number of slaves can be added horizontally. Unlimited scalability. Very high speed processing because of parallel processing, and here can handle all varieties of data, structured, semi-structured and unstructured data, right? Yes. Yes. So open source, right? No licensing is required. Most of these products are from Apache. From the Apache Mirrors websites, you can download and you can install this. One second. Yes. Commodity hardware means it doesn't mean that you need to have highly configured systems. Hadoop can run on any hardware or any systems, right? Doesn't mean that you need to have high config. So mainly these three advantages, right? Unlimited data storage, very high speed processing, can handle all varieties of data, right? So open source, yes. Yes. Yahoo has ta Yahoo has conducted a test by taking a table that's taken as 100 TB data of 2024 columns. Yahoo conducted a test to check the speed of different databases, right? Has taken a table of 100 TB consisting of 1024 columns, task sorting based on 16 columns, sorting based on 16 columns, time taken by different databases. Oracle has taken 3.5 days. MySQL has taken nearly 6 days. Teradata, right, has taken 4.5 hours. Netija has taken 3 hours. Finally, see here, days of time, 6 days, but Teradata is a specialized database used for data warehouse, taken 4.5 hours. Netija, but finally, Hadoop has taken minutes of time. With this, have taken days, this have taken hours, this have taken minutes of time. That is what the speed of Hadoop as compared with the databases, right? Yes. Even talk about Spark. Spark is 100 times faster than Hadoop. Why databases like Oracle can't support unlimited data? Why databases like Oracle can't support unlimited storage? Databases and max limit on the number of slaves. Databases and the max limit on the number of slaves. Oracle, 256 nodes. MySQL, see, Oracle, maximum it can go with 256 nodes. MySQL, max it can go with 54 nodes. MySQL Express, maximum it can go with 256 nodes, means systems. SQL Server with 256 nodes. DB2 with 256 nodes. Teradata, maximum it can go with 512 nodes. Netija also 512. Vertica also 512, right? Yes. But today, currently, Teradata and Netija, they're supporting 1024 nodes. Even though 1024 nodes, right? It's not like unlimited data storage. Once data gets filled, it won't support further, right? Yes. But there is no limit on the number of nodes that Hadoop can have, right? Unlimited scalability, unlimited scalability. When Yahoo first time implemented, when Yahoo first time implemented Hadoop, went with 4,000 nodes for storing its data. Currently, Yahoo going with 12,000 nodes for storing its data. When Facebook first time implemented Hadoop, It went with 8,000 nodes for storing its data. Currently, Facebook going with 54,000 nodes for storing its data. Right? Yes. So, yes, 54,000 nodes. So, Hadoop, there is no limit on the number of nodes that Hadoop can have, right? Unlimited scalability, right? Yes. So Hadoop is proven in the market storage point of view and processing point of view. Yes. Yeah. Just a second. Just a second. Next, how exactly the data storage and processing happening within the Hadoop, right? Yes. How exactly? How exactly the data is stored in Hadoop? How exactly the data is stored? Yes. In Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. Each file is again subdivided. Each file is again subdivided, right? Yes. Into blocks. Each file is again subdivided into blocks. Default block size. 64 MB. See, the file is subdivided into smaller parts and stored across multiple systems. What is the default size? Default default block size 64 MB. In latest versions, 128 MB. It's 128 MB. Latest default block size 64 MB. In latest versions, it is 128 MB. Right. For example, observe this how this data is getting stored. For example, if I got f1.txt file, f1.txt, assume the size is 200 MB. Size 200 MB. Okay. Okay, default block size. Assume the default block size is 64 MB into number of blocks into how many blocks the file is divided. For example, if the file size is in GBs or in TBs, okay, default block, we will get more number of blocks. Here, how many blocks means the file size by default block size, that equal to 200 by 64. That equal to how many blocks? 4 blocks. 4 blocks means this is one block, this one block, this is one block, this is another 4 blocks. This is B1, this is B2, B3, B4. B1 64 MB, 64 MB, 64 MB. Means up to here 192 MB. And in this only 8 MB. 8 MB is stored. Remaining 56 MB free. What is that? 56 MB free. Okay, now that's fine. 56 MB is free. Now f1.txt, assume that it has got some banking data. Assume that it has got some banking data. f2.txt, another file. f2.txt, right? Another file. It has got where it has got some telecom data in it. Assume it has got some telecom data. Okay, here also f2.txt, the size 192 MB. Into how many blocks it is divided? Into how many blocks it is divided? 192 by 64. Exactly 3 blocks. Exactly 3 blocks means 1, 2, 3. Into B5, B6, B7. Into B5, B6, and B7. In B5, assume 64 MB, 64 MB, 64 MB, right? Okay. And here a query. When 56 MB is free in this, when 56 MB is free in this B4, why B5 data is not stored in B4? When 56 MB is free in this B4, why this B5 data is not stored? Means assume, okay, if it is stored, B5 data is stored in B4, assume. Now I'm retrieving f1.txt file. Retrieving f1.txt file means need to combine B1 plus B2 plus B3 plus B4. I need to combine this B1, B2, B3 and B4. B1, B2, B3, B4. For example, okay, it has got 64 MB, it has got 64 MB, has got 64. This 8 plus 56 MB, 56 MB of f2.txt. Now totally you will get 256 MB, but actual file size is 200 MB. You got 56 MB, 56 MB of, I was retrieving the banking data, but I got 56 MB of this telecom data. So this is a wrong computation. So that's why in a single block, like before, no two files data to be stored. No two files data to be stored, right? F1 and F2. In a single block, no two files data to be stored. Yes. Design principles with respect to HDFS blocks. 1 second. Design principles with respect to HDFS blocks. Design principles with respect to HDFS blocks, right? Yes. Every file will have dedicated number of blocks. Dedicated number of blocks. In a single file. In a single file. In a single block. In a single block. No two files data to be stored, right? Every file will have dedicated number of blocks. In a single block, no two files data to be stored, right? Every block will have equal value. Every block will have Every block stores equal value except the last block. Every block stores equal value except the last block, right? Yes. Now I'm going to discuss three cases here. How exactly the data storage and processing is going to happen. In the case one, observe this case one. If the number of blocks, if the number of blocks is equal to the number of slaves, the number of blocks equal to number of slaves. Full parallelism. Very high speed. Very high speed. Number of blocks equal to number of slaves. Full parallelism, very high speed. For example, 4 blocks. Number of slaves. Number of blocks are 4. Number of slaves 4. S1, S2, S3, S4. Yes. For example, I got a file f1.txt. The size is 230 MB. Number of blocks. For example, default block size 64 MB. Number of blocks 230 by 64. 4 blocks. 4 blocks, right? B1, B2, B3, B4. How these 4 blocks are stored across this cluster? This is master, these are slaves. S1, S2, S3, S4. So B1 stored here, B2 stored here, B3 and B4. B1, B2, B3 and B4. B1 in S1, B2 in S2, B3 in S3 and B4 in S4. Okay. Here master node. Within the master node, we see name node. Name node, right? Name node states metadata. Stores metadata. Metadata means data about data. Data about data. It stores data about data. F1.txt divided into 4 blocks. B1, B2, B3. B1 in S1, B2 in S2, B3 in S3, B4 in S4, B1 in S1, B2 in S2, B3 in S3, B4 in S4. Yes. S1, S2, S3, S4. These four blocks are stored in four slaves. So master node stores metadata, that is data about data. So which block stored in which slave, that information will be available. Tomorrow, if you want to retrieve this f1.txt, so this name node has got the total information, right? So it is going to merge the blocks and retrieves it, right? Yes. This is data storage, how the data is distributed across multiple systems. We talk about the data processing. Data processing. Data processing is, right, for example, job is to process f1.txt. Job is to process this file f1.txt. So job always divides into tasks. Yes. Number of tasks in Hadoop always depends on number of unique blocks. Number of unique blocks. How many blocks here? Four blocks, right? So how many tasks? Four tasks. Four tasks here. So here, job to process f1.txt. Job to process f1.txt. Job to process f1.txt divided into four tasks: T1, T2, T3, T4. For executing a B1 block, T2 is for executing a B2 block, T3 is for executing B3, T4 is for executing B4. Think that B1, B2, B3, B4. Okay. 10 lakh records, 10 lakh records, 10 lakh records in this. Mm. Okay, T1 task is for executing B1 10 lakh records. T2 is for executing B2 10 lakh records. T3 is for executing B3 10 lakh records. T4 is for executing B4 10 lakh records. Who should execute this T1 task? Who has to execute this T1 task? There is no other choice, S1 only, right? Because what is this T1 task? Executing this B1. B1 is present where? In S1. S1 only should execute. Who should execute T2 task? System 2. Because B2 is present in S2, S2 only should execute. T3 task by S3, T4 by S4. Means here, four tasks. Here, four tasks. T1, T2, T3, T4. Here, four tasks. Here, four tasks are executed by four slaves. S1, S2, S3, S4. Here, four tasks T1, T2, T3, T4 are executed by four slaves S1, S2, S3, S4 parallelly. Four tasks are executed by four slaves parallelly. Full parallelism. No task is in the waiting state. No task is in the waiting state. Okay. Yes. Four tasks executed by four slaves parallelly. High speed. Yes, this is case one. You observe this case two, right? If you are observing case two. Number of blocks greater than number of slaves. 4 blocks, 2 slaves. B1, B2, B3, B4. Number of slaves, 2 slaves. S1 and S2. Number of blocks, 4. Number of slaves, 2 only. Yes. Number of blocks greater than number of slaves. B1, B2, B3, B4. Yes. F1.txt. F1.txt, right? Yes. I got a file F1.txt. Size is 230 MB only. Number of blocks into how many blocks? 230 by 64. 4 blocks. But assume the number of slaves are only 2. So 4 blocks means B1, B2, B3, B4. Slaves S1, S2. S1, S2. Okay. Master node. Within that we see name node. Name node. Sorry, name node. Maintains metadata. Metadata, right? Data about data. Data about data. It won't store the actual data. Actual data is stored in the slaves. Data about data means this f1.txt divided into how many blocks? B1, B2, B3, B4. B1, B2, B3, B4. B1 stored in S1. B2 in S2, B3 in S3, B4 in S4. How these 4 blocks are stored across 2 slaves? B1 here, B2 here, B3 here, B4 here, right? 2 blocks in this, 2 blocks in this. This is how the data storage happens, right? Now, if you got 10 blocks, only 5 systems. In each system, right? 2 blocks. Each system. B1, B2, B3, B4, right? Yes. Now, data processing. Job is to process f1.txt. Job always should be divided into tasks. Number of tasks equal to number of unique blocks. How many blocks? 4 blocks. Means how many tasks? 4 tasks. Number of tasks. Number of tasks equal to number of unique blocks. Here also 4 tasks means job to process f1.txt. Job to process f1.txt, right? Yes. T1 task is for executing B1. T2 task for executing B2. T3 task for executing B3. T4 task is for executing B4. T3 for executing B3 and T4 for executing B4. Who should execute this T1 task? Yes, try to respond now. Who should execute this T1 task? S1 only, right? Because B1 is present in S1. Who should execute this T2 task? S2. Who should execute this T3 task? B3 is present in S1. S1 only should execute. Who should execute this T4 task? S2 again. Because B4 is present in S2. Yes, S2 only should execute it. So here S1 executing 2 tasks. S1 executing 2 tasks. S1 executing 2 tasks. T1 task and see this S1 executing T1 task and S1 executing T3 tasks. S2 executing, right? T2 task and T4 task. S2 executing T2 and T4. So here when T1 is executing here, T1 is executing here, T3 will be in the waiting state, right? Here in this S2, when T2 is executing, T4 will be in the waiting state. Means only T1, T2 are executed parallelly in S1, S2. Once their execution finished, T3, T4 will be executed. Means if you got 10 tasks, 5 will be executed by S1, 5 will be executed in S2. Means assume there are 5 tasks. S1 should execute 5 tasks, S2 can execute 5 tasks. What happens? Only one task they can execute. Remaining all the tasks will be in the waiting state. Means here some tasks are in the waiting state. So that's why less speed. That's why less speed here. Now observe this case 3. Observe this case 3. Case 3, right? Yes. Number of blocks equal to 230 by 64. 4 blocks. B1, B2, B3, and B4. How these 4 blocks stored in a single slave? This is the master, only one slave this time. S1. So this is the master node, is a name node. It maintains the metadata information. Metadata means data about data. Data about data. F1.txt divided into how many blocks? B1, B2, B3, and B4. Where B1 stored in S1, B2 S1, B3 S1, B4 S1. So B1, B2, B3, B4, all the stored in S1 only. Mm. So this is how the data storage. Now data processing. Data processing means right. Job to process F1.txt. Number of tasks equal to number of unique blocks. number of unique blocks. How many unique blocks here? 4 blocks. I'll say why I'm saying the word unique. So this four tasks. Four tasks means T1, T2, T3, T1, T2, T3, T4. Who should execute this four tasks? Only one system is there. T1 by S1 only, T2 by S1 only, T3 by S1 only, T4. So all the four tasks are executed by single slave sequentially, one after the another. So there is no parallel processing here. It takes lot of time, right? The case one, four tasks, four systems. Each task takes 1 hour. Total four tasks takes 1 hour only. In case two, four tasks, two slaves. First two tasks will be executed in by two systems. 1 hour it takes. Next again two tasks. So totally 2 hours it takes. For example, case three, four tasks, only one slave takes 4 hours. Each task takes 1 hour, right? So more tasks, more slaves, more speed. Less slaves, less speed. If only one slave, no parallel processing. So if you go back to this case one, observe here. Here T1, T2, T3, T4. Four tasks are executed by the four systems. You see, B1 has got 10 lakh records, B2 10 lakh records, B3 10 lakh records, B4 10 lakh records. Four tasks are executed by the four slaves, right? Four tasks are executed by the four slaves. Suddenly, if any one slave goes down, you see two drawbacks here. 10 lakh records are lost. 10 lakh records are lost. It's the first one. And the T2 task is failed. T2 task is failed means entire job is failed. So here task failure you can see and data loss 10 lakh records. 10 lakh records if it is sensitive data like banking data, huge loss. But if it is non-sensitive data like social media data, it's not a problem. But so here data loss and the task failure. How Hadoop is able to overcome this means there's a concept called fault tolerance and replication, right? So in the tomorrow session, I'll be briefing you about this fault tolerance and replication. Fault tolerance and replication, right? Yes. So when I'll start with the practical part, I'll be taking more time. Tomorrow, like I'll be taking class from 4 to 5:30. Tomorrow will be same link. Okay. So sorry, tomorrow you will get a new link. So try to get enrolled. If you're not enrolled, try to get enrolled. So you'll get a new link to your mail. Tomorrow, a new link. Check that new link. Yes. And if you're not enrolled, you can see in the chart, the payment details is provided, course content details are provided. You can check with that. So tomorrow, my discussion will be fault tolerance and replication, right? The contact details of the online team, you can see the payment details, you can see, and their Google Pay or Phone Pay details. Yes. Okay. 4 to 5:30, but a new link, the link you can see in your mail, a new link you will be seeing. If you not got the link, you can see some contact details are there. You can contact that contact, 3 numbers are given, right? Contact them if you not got the link, right? So tomorrow I'll just discuss fault tolerance and replications and Hadoop architecture I'll be discussing tomorrow. Storage architecture and processing architecture of Hadoop. Once I complete that, I will go with the practical part, right? So first, some two sessions we'll be having, but later everything will be practical oriented, no theory, right? Fine. So I'll stop for now. We'll continue tomorrow at 4 o'clock, right? Yes.